Okay, thank you, sir, for introduction. I'll do a very short prayer and then I'll begin. Om Jnana Timrandasya Jnananjana Shalakaya Chakshu Anlitam Yena Tasmai Shri Guruve Namaha Tasmai Shri Guruve Namaha. So happy to hear from the morning, lot of wisdom flowing in the hall. From the inaugural dignitaries to our Professor Home to our Professor Joshi, lot of things good. So my presentation will be, I will make a short little bit introduction about the issues in quantum foundations. Very short introduction, not going too much into details, but to give you idea. Those who are not in too much in the field, those who are in the field in quantum, they will already know it. But those who are not or new to it, that will be very useful for them. Just to give you idea and then possible connection with our Indian knowledge system. Okay, so we are celebrating 100 years, right? So our Professor Home was mentioning. This is the island of Helgoland in Germany, where Heisenberg went there in 1925 in June in this month. A beautiful island. Actually, we were trying to go there, but there was a date clash. Just after our conference, their conference is starting. There, June 9 to 12 or 4 or 5 days. A lot of good scholars are coming from various parts of the world, from Yale University, from Max Planck, from that Canada Theoretical Physics Institution. Very good gathering is going to happen, but the dates are clashing. So this is a very good gathering, and just purely in honor of this 100 years. So I thought to show you, if you get a chance in your life, you can visit it. A short island, you have to take a boat from land in Germany, from Munich, and then go to visit that island. Okay, so the direction will be like this today. Uh, we'll have a short introduction and then an overview of the issues in quantum foundations. Means when I say quantum foundation, means it's a short name of foundation of quantum physics. And then a few insights from our Indian knowledge system for some of these issues, possible insights, not the answers, just a possible thoughts. And then some concluding remarks. Besides 100 years of quantum, we are also have a 50 years of our institute, Bhaktivedanta Institute, started 1974 by this person called Dr. T.D. Singh. He was from Manipur. He went to America for a PhD in physical organic chemistry in UC Irvine, and then he started the institute 1974. So by the inspiration direction of his guru, and then this institution is running 50 years now. This is part of this celebrations too. So we started these celebrations with a Phillips lecture. Laser man, very nice gentleman. We know him very well, many years, good friendship. In Maryland, he is now. He gave a lecture in the 24th January, starting as our 50-year celebration. And then we had summer school last year on origin of information, because now quantum information is becoming very prominent. So we had a lot of good deliberation. Our Professor Pati was there. And then we had two important talks by Wineland, also in laser and physics, and then Meldal in chemistry. Both of them as a part of these celebrations this year. One in last year, November, one in April, just 1 month ago. And then we had a conference in Vijayawada in a School of Planning. This is our regular conference, Science and Spiritual Quest. And we invited Genzel. His talk, very good talk on his work in cosmology. He got Nobel Prize because of black holes. So very nice. We met him, very nice gentleman. So he agreed to present in this very nice talk he gave. So these are some of the things which we have been occupying. Last 24 August, we had a conference on consciousness in Yadavpur University. Many good scholars presented there. And these are some of the books from our institute. This one is quite prominent, Quantum Physics and Consciousness, because the first big section contains thoughts of prominent founders, Bohr, Schrodinger, Planck, Heisenberg, and all. This is a founder with Penrose. We have a small booklet, but very good booklet. Like we had Schrodinger's booklet, What is Life? I found very interesting points Penrose mentioned in this. And then Dr. Singh himself, the founder, wrote a book, Consciousness, small booklet, but these are very good, relevant for exploring quantum physics and consciousness theme. Okay, so these are some of the books which have been occupying us, and it could be a great resource for all of you who are interested in intersection of physics and consciousness or physics and mind. This is physics and philosophy, like our professor Home was mentioning, Physics and Beyond. That was another book by Heisenberg. But this is one book which we are very close to our heart, Physics and Philosophy. Heisenberg speaks many, very good things. If you are really serious about it, the things which you are talking today, you can go and get this book. Now it's all available, soft copy or even Amazon, you get it. Then this is famous, you know it. And then philosophical problems, again by Heisenberg. Bohr, of course, light and life. Then where is science going? Max Planck. And this is Pauli. There were discussion, a lot of good things, thoughts about Pauli, from Pauli. And then Schrodinger, another book, Science, Theory and Man. So some of these, what happened was that, to give a personal note, my first introduction to quantum physics came in 30 years ago when we were doing our B.Tech in IIT Kanpur. First year, we were attacked with a quantum chemistry course, 101. And then we came from a simple home background and attacked with matrices, partial differential equations, and big thing. So that was the first blow to our mind, that 1995. So that was the first introduction, that what is this quantum, that was introduced through quantum chemistry, but you are straight introduced to Schrodinger equation in the first year. And then very nice professor was there, Professor Tulsi Das, you must be knowing, our Professor Chakravarti is from IIT Kanpur. So Professor Tulsi Das offered a very special course, first time in the history, I think, in IIT Kanpur, Physics and Mind. That was very amazing course. He offered as a side course, but everybody is free to join. So we attended that, and this further catalyzed our thoughts of connecting quantum to something philosophical or beyond. And then thirdly, of course, Dr. Singh, Dr. T.D. Singh, who crystallized everything, and he asked us to focus on these founders of quantum physics. He said that besides their papers, you read their own works. So that's how this 30 years journey of institution has been going in this direction, primarily based on the founders of quantum mechanics. This was the kind of small introduction we had. So thank you to all our teachers. Because of them, we are here today. Okay, so we go to part, what are the basic introduction to the, what are the basic issues? I will be little pedagogical, just give you some ideas. What are the issues in quantum foundations? See, there are 5 issues in quantum foundations, which are very, very important. And some people realize some people realize other, but all 5 are equally mind-boggling, and they are puzzle from last 100 years. Some are very prominent, some are less prominent, but all are still troubling. First is wave nature of matter. Second is non-locality. Third is measurement problem. Fourth is uncertainty. Fifth is meaning of wave function, or if you want to extend superposition too. So it's like we used to have a course in our engineering times. So quantum foundation course in 15 minutes, 101, 201, because we are going in the foundation, not the equations. So I'll very give you a very brief idea about these 5 issues, why they are still issues today. This Feynman, Caltech physicist, prominent, everybody knows, he did a very good work in quantum electrodynamics. So he mentioned that the whole heart of quantum mystery lies actually that how come matter particles display interference. That was a big blow. Means you see when you see the light, when you see a light passing through a slit, you see the interference pattern. Fine. When you send electrons and see interference pattern, that is little shocking. Why electrons? Means why matter behaves like wave. That is, see that if you have to little bit meditate sometime, close your eyes and you have to meditate, what does this mean? Why this matter, all this matter in this universe, why this behaves like a wave? So that has been puzzling if you deeply think about it. So that is what it is saying here. We see by wave. So this history, everybody that more or less all of you in physics background, that how the particle and wave behavior moved from light. First we saw light particle, then light as a wave. Then it came to electron. So, but when it came to electron, that how matter behaves like a wave. So nowadays it is a very common phenomena. This is a interference pattern of electrons, a stream of electrons, not of light. So how come electrons are behaving and giving interference pattern, behaving like a wave? That has been shocking and still not able to digest it in 100 years. Though we have made a nice word, wave particle duality. Word is fine. You combine two words, I put a hyphen, but are you able to digest the meaning of it? There where lies the question. So this was not only me and you, De Broglie, who gave this idea actually originally 90s. He himself was puzzled. You have to see his book. There's a very beautiful book by De Broglie, which is lesser known, The Revolution in Physics. If you can get a chance to get into it, this is a soft copy also available. Very good things he talks about. So he says that I myself was shocked that suddenly I had this idea that wave and particles is true for all matter. But what it means, I am really puzzled. And this is very common thing now because we have tremendous experiments one after another to collaborate that matter do behaves like a wave. We have interference patterns. Today you find so many experiments to see the single electron interference experiments. This is one of them. So this wave nature of matter has tremendous philosophical implications. That is why this is one of the thing. These are open issues, no conclusions, open exploration. Wave-like associated with matter, what does that mean? De Broglie himself is puzzled. So it means that physical matter may not be the final reality. This is one very interesting observation coming by the scholars, that if that is the case, then physical matter, there's something more may exist behind this physical matter, which is wave-like in the reality strata. This is strata, reality strata. So if universe is like this, then we ourselves who are part of this universe, do we also have some kind of characteristics beyond this physical body which we can touch? That's the idea. Second is non-locality entanglement. Our professor Home spoke about it nicely. Is a very hot issue, and we are yet trying to use it for many things for developing quantum. This was the issue among Einstein and the Copenhagen team. Lot of issues. We heard some lectures last few days online as a part of these celebrations. So there they expressed a lot of good things. So this entanglement issue is very simple, that we find some communication going on. Um, idea is very simple. Instead of going in detail, idea is very simple, that as per Einstein established that any communication within a space-time fabric has to maximum can proceed by the speed of light. But then when we find that entangled particles, the signal is communication is happening. If you alter a state of one particle here, another particle state is changed, which is instantaneous. That means there looks like this communication is happening even beyond a space and time fabric. It is crossing the speed of light. So that means there is looks like something. This is the principal locality as Professor Home was mentioning in physics. So already explained. So these experiments have now very well established experiments. There were a lot of doubts about these experiments actually, entanglement experiments, that whether they are just speculation, some scientists are proposing it, or they are really true. So, but now it's a very good, now you can search very, very good development. We talked to many experimental phases. Now it is very, very well established thing. And after Nobel Prize in 22, people are already feeling comfortable. 1972 Clauser experiment, then Allen experiment in 82, which established very clearly the entanglement aspect of what we are talking today. So this is 22, which was awaited from last many years, because after Bell, lot of years passed, but finally it came recently. So of course, there are many experiments. This is Antony Swaraj. This is one of the colleagues who is associated with us in Zurich. He performed many experiments too in this direction along with Bell. Before Bell, he was working with John Bell actually earlier. Now he's there. He just gave a lecture 2 days ago in our Quantum Week celebrations. So they had good experiments. He was explaining the detailed experiments. So of course, these are tremendous application. I think our Professor Pati is going to express this heavily, strongly about all these applications, I'm sure. So, but then besides the applications, there are questions how it works still, though we are using it. And the implications. The implications are there seems to be a reality beyond underlying connection of things at deepest level beyond space and time fabric. That is a kind of thing if you go deep into non-locality. You have to go deeper. I'm trying to give you a glimpse, but that's the kind of conclusion comes that the space-time fabric is not sufficient enough to sustain the conclusions of quantum non-locality or quantum entanglement. So that is the kind of things which comes out, but you can always talk about it openly. And since problem is that we are also part of this universe, so any implications which comes on the reality, on the fabric of reality, also comes to us too. So that is the thing which gives a lot of insights to our Indian knowledge system. Third, measurement problem, very interesting problem. This is the heart of quantum mechanics, that how measurement affects the outcome. So that you know that double slit experiment, you put a detector and the outcome changes. Those are very famous experiments, which famous aspects in quantum mechanics which have puzzled. This is still a big question, and it has many names. One of the thing which simply to put it is like this: Schrodinger's cat paradox, which is a famous paradox. Is called a thought experiment, not a real experiment, which many of you might have heard. Idea was this, that we have a box, closed box, and there is a cat there, and there's a beaker with the milk. Milk has a poison in it, and there's a hammer directed to it, and we have a giga. There's a box with some atoms or radioactive atoms, 3, 4 radioactive atoms, and then so we don't know whether the atoms will. Suppose you have 3, 4 atoms, we don't know whether the atoms will decay because radioactive half-life is statistical. So is the statistics, means it's not the exactly 50% will finish. So at any given time t, what is the state of this box? So it comes out that okay, both possibilities are there. Cat could be alive, cat could be dead. So as per the our physics, quantum physics, we say both the combination of both possibilities, cat alive, cat dead. So this kind of paradox, because it is not possible in reality, cat being alive and cat being dead. I explain you a simple giving example from my side, a thought experiment, simple thought experiment. Suppose you met a scientist He was 10 years ago, he was 90 years old at that time. Okay. Now, when you are thinking about him now, after 10 years, in your mind, both possibilities exist. He could be alive or he could be dead. Now, physics tells us that any given point of time, the state of scientist is scientist alive plus scientist dead. Both possibilities are existing. So, interesting aspect is, Schrodinger, I am very thankful to Schrodinger and Heisenberg, especially. These two people are contributed a lot to the foundation, especially. You see, it has brought to a limits of limits. The extreme case means, now you see these two possibilities: scientist is alive and scientist is dead. They are not possible in physical world. Either it has to be alive in physical world or it has to be dead. But these possibilities, quantum physics is correct. These possibilities are there. Then where are these possibilities? So there comes, that means we have something called mind where these possibilities are there. Both possibilities are still existing in mind. As long as you try to reduce that mind to physical world, you get a paradox. That is why we have a paradox. But these possibilities are there in our minds, both. So when you call or talk to somebody, you get the information and then converting possibilities to the one state. So implications of measurement problem is a huge. If you have to deeply ponder it, it is not a normal equation, Schrodinger equation thing, or is a very deep implication. That's why people are bothered. What is actually measurement means? For example, when I go back to this cat cat thing, you see this system remains in this state only till I open the box, and then at that time, okay, cat is either alive. One answer comes, either cat is alive or dead. So when you open the box, that kind of measurement or observation, then what is happening at that point? That is exactly the question. Uh, so then you can put it more deeply. What is really measurement? Then you go further. What is really the act of observation? Means when I observe, what happens? You go deeper. Who is really the observer? Because the problem is, if you take me, my body reduced to atoms, then finally to electrons, and all electrons can be expressed as wave function, then finally who is observing? Everything remains like a possibility only, right? Finally, from where the observation coming? So then, if you go deeply, who is really so these are deeper and deeper questions which have bothered actually in the measurement problem. And people have deeply pondered, like one of the nice thought processes from von Neumann in his Mathematical Foundations of Quantum Mechanics. You can read his last chapter of this book. Full book is full of mathematics, but in the last, he gives very nice insights. If you see without mathematics, you will see that that's what I was telling. Okay, I have a body, myself, or system, retina. Okay, observation. What is this act of observation? Means retina. Finally, somewhere somebody has to see, right? Everything can be reduced to wave function. Then finally, how do you get from possibilities to one actual thing? This is called name as von Neumann infinite chain. That is what I was trying to explain, that there's a difference between observation versus instrument observation. When I see, okay, then eyes is involved, you go deeper, retina is involved, you go deeper, this neurons are involved, you go deeper, you get into protein structure, DNA structure, but finally who sees? None of these sees. So these issues come as a part of observation or act of observation. So to put it nicely, actually this is von Neumann insight. I have put it in a form of equation. That act of observation involves four elements. One is the object you are seeing, that is one. The instruments, the eyes or microscope, which you use to see. Third is the experience, you have experience. You, as a conscious observer, you have experience, which is missing in the machine. Remember this. This is a very big point. And third is finally, who is experiencing the experience? The subject or self. So there are four elements in this act of observation. Remember, our whole scientific development starts from observation. And we are coming back from quantum physics back to the beginning, what is actually observation. So this in Western world, this is a conscious experience subject. They are all combined together as termed as consciousness. But in Indian tradition, we have a lot of details. So this equation of act of observation is very close to definition of actions in our Vedanta. There are 5 causes of action, which I think Vasudev, my colleague, tomorrow may cover in detail. This conscious experience is an important thing because each one of us have it, cannot deny it if we are honest. And then, for example, one of the example of conscious experience is understanding. This is very important. Roger Penrose talks a lot about it. You see, AI does things, machine does things, computer programming does things, but I understand. Do they understand? They process, they compute, but that understanding, that part, where is that? This is not only Penrose. If you go deep into the Niels Bohr and Heisenberg discussion, the same thing came when Heisenberg started questioning why we are not able to understand nature like this. Then Niels Bohr put the question upside down and say, that means you have to question what is understanding itself now. So it started actually in the beginning of quantum foundation. Now more and more Penrose is taking, all these are part of consciousness. Understanding is actually one of the properties of consciousness. Then of course you can go to next question, who is understanding finally at the core. To put a simple example, you see both, here is observation is going on, is a nice boy sitting, is a cosmology, right? Professor Joshi may like the picture. And so here telescope is there. But then you see common is there in the both the pictures. I have retina, there is a lens there, much more maybe better lens in telescope. Information processing is there, you can do data analysis there. But there are something in the right side which is missing on the left. One is experience, another is who the core observer who is experiencing. These are the some of the issues which come in the quantum measurement issues deeper. Of course, last is uncertainty. Fourth one is uncertainty. You know that as we moved from classical to quantum, this uncertainty was a big shock to Heisenberg too, and to everybody, that how come we were so predictable, we can precisely predict, how come this uncertainty came, which we are not able to avoid it. It's not just a simple equation, it has tremendous implication. Why things are uncertain at the core? Why? Means why we are losing the grip that we had in classical physics. And last is this wave function, meaning of wave function, these 5 issues. So this is Penrose that if you go to a course by almost anybody on quantum mechanics, you are supposed to get through an exam. You are not supposed to ask questions about what things mean. So this meaning is a big issue actually in quantum physics from 100 years. Why, for example, wave function. If you Google it, or we have so many meanings of wave function by all renowned scholars. Heisenberg has another meaning, Bohr has another meaning, and today you have so a lot of meanings in the line from scholars, living scholars around the world. So what is actually this psi? We were trained very nicely, del square psi by dt square, to solve this equation of electron in the box. But what is this psi? Schrodinger had a question. In fact, if you read the earlier papers of Schrodinger, the very nice joke, his friends used to play with him. Schrodinger has done a very nice equation given, but only thing is missing is he does not know what is psi. There's a nice poem actually. You go into the old papers, you will find it. So Heisenberg put this very nice way. It was not a 3-dimensional wave like elastic or radio waves, but a wave in the many-dimensional configuration space, and therefore a rather abstract mathematical quantity. That this is the beginning Heisenberg came to that point. Our professor, I think Tejendra Singh, tomorrow he will be presenting probably. So he will be going into higher dimensions to there. It may make sense, this quote more. Of course, we define this as a collection of possibilities. This is one of the ways. But what are these possibilities, the quantum states, and where do they exist is always an open question. Okay, so last part, the section 3, some insights, some possible insights. If you like something, you can take it. If you don't like, you can just leave it. Not a big problem. These are some thoughts, some insights on these 5 aspects: nature of life, nature of reality, nature of mind, nature of consciousness, nature of concepts in physics. Our Indian knowledge system says that life is not matter, straightforward. There is no ambiguity there. Life is not matter. We have been trying last 500 years to reduce this mind consciousness to the brain, to the neurons. No, it's not. It has correlation, not causation. We have to be very clear as per Indian knowledge system. Life has a 3 parts: physical part, which is one of the parts aspect is brain, the physical body, which you can see, touch; psychology aspect, which you all have, but you cannot see, you cannot touch, mind, mana. The spiritual part, whatever name you want to give, soul, atma, jiva, whatever, that consciousness is a property of that. So, because since we have been trying to reduce all this life to one part, we are facing so much foundational issues, and one of the issues is consciousness. In fact, you will be surprised, consciousness is not the only issue. We have 15 issues actually, which you cannot solve if you still stick to the definition of life, which we have been trying from last 500 years, somehow reduced to neurons. See, original life problem, we are not able to solve. We had a summer school there. We had a summer school full, many actually beautiful talks from scholars on, we don't know how first cell came. We cannot. You can play the existing living cell. You can do biotechnology and play. But to create a living cell is the issue. That's called a technically origin of life problem. Issue of consciousness, which we are discussing today. Issue of free will. We don't know, and we will never know unless you really expand this definition of life. Issue of purpose. Living system is very different. AI, very advanced, but still you are the one who give it purpose. AI does not have its own purpose, right? Then what is there extra in you which is not there in AI? Where from this purpose comes? Issue of meaning, you always search for the meaning of things. Issue of responsibility. If something goes wrong, who is responsible? If AI does something wrong, who is responsible? If you have now Tesla cars, right, in America. So if something happens, who is responsible? Not just the chips, right? Intelligence, issue of understanding, numbering, gratitude, compassion, memory. We had a full summer school on memory 2 years ago. These are issues which are not solvable without expanding to Indian knowledge system. And already brilliant thinkers are moving towards that. This is great thinkers. This means you cannot reduce things to just physical. There's a biologist, where you know it, physicist Fagin, becoming very prominent in Europe. He was who discovered this chip. He spoke last in our conference in Yadavpur conference. He spoke very prominent, getting now Federico Fagin, originally physicist by background, and they're psychologists, irreducible mind. You cannot reduce mind to just brain. That means they go so deep. I myself don't have that capacity. You have to yourself go into them. But I met them, I know them, their work, some ideas. Second aspect is nature of mind. Well, mind is not a classical object as per Indian knowledge system. It is a more like a quantum object. I can go later in detail in person if you want how it is. Sure, sure. We'll finish 5 minutes. The nature of reality, reality is not just physical, as we have physical sciences. Physical sciences are good, but they are only a limiting case of overall sciences. One case, like you say, limit tends to limits. The specific case. So there's a psychological aspect which each one of us have, and there's a spiritual aspect too. In consciousness, nature of consciousness, there are two aspects, individual consciousness and infinite consciousness. This is one of the things which we mess around, then a lot of issues come. I really don't know what is happening in your stomach. I really don't know. Means my consciousness is limited. I don't know every space and time in this universe. There's a difference between individual consciousness and so you have to remember this when you go into the quantum foundation issues. Otherwise, you get messed up in the conclusions. One other thing, which simple thing, I think you are going to hear a lot about it, is just a side thing, not a main thing. You see this possibilities, so various possibilities which we talk about. So this is one example that in which we talk in our actually Vedanta. You see, when suppose this example here, suppose you are at the door and you have when you are leaving in the morning, you have various possibilities in your mind. I to go to friend, to office, to a park, to relative, right? So all these possibilities exist in your mind. You choose one among them. So these possibilities cannot exist simultaneously in the physical world. They are not possible physically. You can be only at one place, right? But in your mind, they are existing simultaneously. So I think Professor Haridas is going to speak about superposition, not going into all those, just the idea that in there is a difference between Indian knowledge system and West, that even consciousness is even different from mind. Means you choose among various possibilities in your mind. That means you are even different from above your mind. That is very interesting aspect contribution from IKS. In West, mind and consciousness are considered all same. Okay, this is consciousness incompleteness. How this comes? Let me give you idea. They are not wrong. Actually, Heisenberg came to the point when this quantum foundation issue came, that whether this concept of position, concept of velocity, they are correct in Newtonian domain, whether they are correct in absolute domain. That's was the question he put. I request you to go in detail. Physics and Philosophy, page number 85, Heisenberg, he says, they were they were not well defined as seen from the relations of uncertainty. He questions the very concepts which we use. He says they are not wrong, working well in classical, but when it comes to the question of defining absolutely the concepts like position, what is actually position? There he questions it. So take for example the concept of force. We have we have we have a concept physical force, right? Force, this we all trained, force equal to mass into acceleration. It works well coming from Newton, our Newton mechanics, Principia Mathematica, from Newton's, right? So this is a physical force, but then there are various forces as per our Indian knowledge system, not just physical. We have psychological force. You want to do something, but your mind is pushing to do something else. What is that force? That force is there. Then there's a will to do things. You want to do, really, there's a will. What is that force? So, as per our IK system, force is not just physical. This is a famous example for students that tomorrow you exam and your mind is pushing you to go to movie. So, where is that push coming from? So, that is, idea is this, that the force is, there's not only physical force which is studied in physical sciences, there's psychological force, there's spiritual force. Similarly, all other concepts, if you go deep, they are need to be expanded if you look from our Indian knowledge system. This is not my idea actually. If we go in the roots, this is rooted from Gödel's incompleteness theorem, which says that because all these concepts are based from mathematics, so in mathematics, you know Gödel's 1931 famous incompleteness theorem, that they are incomplete without bringing in mind or consciousness. That's the roots of all this if you are really interested to go deeper and deeper. So I end with this, that I propose, as per our founder's vision and direction, that we need synthesis of subjective and objective interpretations. And that's what Schrödinger told, that our Greek science do need a blood transfusion from Eastern knowledge, Eastern wisdom. And these are possible future ideas that thought experiments quite be useful when we move deeper into quantum foundation issues. We need to include medical field, the doctors and medical professionals, because the question of sleep and various states of consciousness are being, we had a recently a conference in AIMS, so we started a little work in that direction. And then of course role of meditation practitioners, because these meditation practitioners, you can go various states of consciousness which are really not known in general. So I end this here. For our side, from our small brain, if you really want to handle foundation issues of consciousness and other issues, you need synthesis of science and spirituality. This our Indian former President Pratibha Patil mentioned in our lecture, in our conference. Not only you need heart transplantation from modern science, you need heart transformation too from spiritual tradition. Thank you very much.
Thank you, Varunji, for a really beautiful lecture. The first part, physicists are familiar with quantum foundations. The second part was especially enlightening. You really hit it hard. That there are, you hit the problem very nicely.
No.
It's clear that there are things which cannot easily be translated into the language of physics as we know it now. Thank you very much. So talk is open for questions. If there are no written questions, that is good. It means we have about 5 minutes for discussion. So please feel free to ask. I think he's been very provocative. Uh, so could I ask you, are you saying that individual consciousness is a subset of universal consciousness, or they are distinct?
They are distinct.
Yeah, so I'm very puzzled. You take the simplest of viruses, the first life form. So it has, according to you, an individual consciousness.
Well, virus is the issue still today, whether it is life or not. So we can talk something else.
Yeah, no, okay. Whatever you call the simplest form of life, according
We can take single cell. Single cell.
single unicellular living organism has an individual consciousness.
Yes, as per Indian knowledge system, Vedanta,
Mhm.
even the single unit cell has consciousness. Actually, in fact, you will be surprised. There are beautiful works in this direction. The scientists who have worked 40 years, 50 years only on microorganism, and they come to the point, when this tiny single cell bacteria, what microorganism, when it moves, it has a will. It is not a random walk. It moves with a will towards a food. You go deeper, it's really very interesting. You can go in deeper inside. They have a element
So
of
these
consciousness.
famous experiments where you, like Harold Urey's experiment where you bombard, say, molecules like nitrogen, carbon, oxygen, hydrogen with light, you form organic molecules. So that you are okay with. That is not having individual consciousness, but somehow when it becomes a cell, something happens.
Yeah. See, the Miller, you mean to say Miller experiment?
Yeah, Miller. Yes,
Tell-
sorry, I missed Miller. Yes.
No problem. Miller, you see, Miller came, when Dr. Singh was doing his PhD in America. So Miller came, and if you see the later papers of Miller, he confesses that actually we have tried our best to put amino acids together to produce further and further bigger molecules, but then we don't see any symptom of life there.
So what or who puts individual consciousness in a cell?
Uh, yeah, it is an open question, but this much is clear that there is a consciousness in the living cell. That much is clear. But who possesses it? That's up to researchers.
The 5 fundamental issues that you talked about.
I hope they were not wrong.
Do you believe
Huh?
that? Do you believe that anyone who has an experience of what consciousness is, these problems are not a problem for them? These fundamental issues, right?
Okay.
These fundamental issues are staying since last 100 years to the normal people, to us. students of science, engineers, right? But anyone who understands consciousness, who not only understands by bookish knowledge, who has truly
Real-
experienced,
Realize it.
like, yes,
Yeah.
many of our Indian yogis,
Mm.
they had these experiences, right?
Mm.
They truly understood that what consciousness is.
Right.
Do you believe that for them, these issues are not issues at all? They have answers to all these mysteries. The yogis we know, Indian yogis, if I talk about, I am certainly sure that they did not study quantum mechanics,
Correct.
right?
Correct.
But if they studied, did they feel it so difficult? What we are discussing, that it's so difficult, 100 years, we have not solved, we have been able to solve this mystery.
Got your point.
What do you think?
Okay, got your point. You see, there are two things to note here. One is that quantum physics can possibly give some indication of things like consciousness. It will not give you details about consciousness. It will not tell you what is really consciousness, what are the states of consciousness. This will not tell you all this. It can give you some direction, hint. Okay, there is something there, go there, like that. Hints. That is one part. So that is one good element you can take from foundational issues if one is interested in. As far as the rishis and yogis are concerned, you see, if they have realized what is consciousness, doesn't mean that they know partial differential equations. You see, you have to give them little compassion. No? Be compassionate on them also. Like they are compassionate on you, you be compassionate on them. We don't expect them to solve matrices and reply your quantum operators, you see. They can tell you the overall ideas. See, that's what I'm trying to express here. In your knowledge system, we don't, in Gita, I don't find matrices there, you see. I don't find partial differential equation. But you get a bigger picture. You get a better overall idea. Same thing they can give you also. That these issues are arising, like I hinted in between time to time in the lecture, the issues are arising because you are trying to reduce everything to the physical world. Physical sciences, quote unquote. Remember, our issue has been rooted in two things in modern science because of which you are facing paradoxes. One
Sir,
is,
Sir, if you don't mind,
uh,
we have one more question.
Sure.
But I want to request, I think this is a very important interaction between physicists and sir, people like you. Can you set aside some time, like half an hour, 1 hour today or tomorrow, where I have many things to ask him, other people also. Yeah, so because you see, this kind of union is rare. You probably meet physicists, but physicists like me don't meet often people like you. And there are lots of things to be asked and lots for me and us to learn. So please, sir,
we can share. Yeah,
yeah,
we can
yeah.
share.
The whole audience. The last question.
Yes,
To
Professor.
illustrate these issues, one point, there's a very important question of time, which is missing from the whole of lecture. The awareness of time
Very good,
and
very-
also the arrow of time.
Very good.
Now, I just can elaborate with that
Yeah, yeah.
session.
I think
And
we-
now also I had paucity of time, and in my slides that I talked about, well, Legetkar, realism, all these things, one important assumption missing there, which is again related to time, which I did not go into
Very
because
good.
I expect Professor Leggett will bring it up.
I think,
That
yeah,
is the
I
assumption of
I-
arrow of time, which is used in all these derivations of Leggett-Garg,
Sure.
Bell, and that which is called the assumption of induction, that the property is dependent only upon what is that, how the particle or anything is prepared at the source.
Correct.
There is no retrocausality. So that is a deep issue, the order.
Sure.
of
We can, I think we can add time. We are good,
Thank
good
you.
session.
We'll continue. We'll continue.
consciousness also is because
Yes.
we are aware of the error.
Sure, sure.